Hello and welcome to my channel Networking with H. In this session of CCNA series, I'll be discussing about two types of network topology architecture. The first one is three-tier architecture and the second one is the two-tier architecture. Building a campus network is more than only interconnecting physical network infrastructure devices. The most challenging and the important part of it is the planning and the design phases, where different technical variables and technologies need to be considered that could even affect the product selection and the design entirely. Network designers do not just plug in devices to any port and connect switches to each other in an arbitrary way, like you might do with a few devices on the same table in a lab. Instead, there are known better ways to design the topology of a campus LAN. Cisco hierarchical network design model breaks the complex problem of network design into smaller and more manageable one. Each layer or tier in the hierarchy is focused on specific set of roles. This helps the network designer and architect to optimize and select the right network hardware, software, and feature to perform specific roles for that network layer. The two proven hierarchical design architecture for campus networks are three-tier model and two-tier model. A typical enterprise hierarchical campus network design includes the following three layers: core layer, distribution layer, and the access layer. Three-tier model includes all the three layers. This design model can be used in large campus networks where multiple distribution layer and building needs to be interconnected. Let's begin with the access layer. The access layer is the first tier or edge of the campus. It grants end devices access to the network. As shown in the figure, the access layer network generally incorporates layer 2 switches and access points providing connectivity between workstations and the servers. The access layer provides the intelligent demarcation between the network infrastructure and the computing devices that leverage that infrastructure. It is the first layer of defense in the network security architecture and the first point of negotiation between end devices and the network infrastructure. When looking at the overall campus design, the access switch provides the majority of these access layer services and is a key element in enabling multiple campus services. The second layer we have is the distribution layer. The distribution layer in the campus design has a unique role in that it acts as a services and control boundary between the access and the core. The distribution layer, on the other hand, serves multiple purposes. It is an aggregation point for all the access switches and acts as an integral member of the access distribution block, providing connectivity and policy services for traffic flows within the access distribution block. The distribution layer aggregates the data received from the access layer switches before it is transmitted to the core layer for routing to its final destination. A distribution layer switch may provide upstream services for many access layer switches. In the figure, the distribution layer is the boundary between the layer 2 domain and the layer 3 routed network. Either a router or a multi-layer switch is used in segment work groups and isolate network problems in a campus environment. The third layer we have is the core layer. The core layer is also referred to as the network backbone. The campus core is in some ways the simplest yet most critical part of the campus. The core layer consists of high-speed network devices such as the Cisco Catalyst 6500. The core aggregates the traffic from all the distribution layer devices and are designed to switch packets as fast as possible and interconnect multiple campus components. As shown in the figure, the core layer is the critical for interconnectivity between the distribution layer devices. For example, interconnecting the distribution block to the WAN and the internet edge. It provides a very limited set of services and is designed to be highly available and operate in an always-on mode. In the modern business world, the core of the network must operate as a non-stop 24/7, 365 days in a year. The key design objectives for the campus core are based on providing the appropriate level of redundancy to allow for near immediate data flow recovery in the event of any component failure. Next, we discuss about two-tier model. This design model is more suitable for small to medium-sized campus networks. Many small enterprise networks do not grow significantly larger over time as large organizations grow. In such a network, the core and the distribution functions can be combined into one layer called collapse core, also known as collapse core distribution architecture. A collapse core is when the distribution and the core layer functions are implemented by a single device. The primary motivation for the collapse core design is reducing network cost while maintaining most of the benefits of the three-tier hierarchical model. That's it about the two-tier and the three-tier model. In my next session, I'll be discussing about leaf and spine architecture. Thank you for watching. Please do like, share, and subscribe. And do not forget to hit the bell icon. Thank you.